Hello and welcome to this tutorial on Simulink for STM32 microcontrollers. The first thing that we need to do is download the STM32 support package for MATLAB. And we can do this by going to the Google and searching for STM32 Simulink. We open the file, the website from ST website, and we download the installer. You will need to provide the email address or some other information for downloading that. You can click in Get Software and accept the contract. Fill this information and you will get an email with the download link. After installing this, we need to install the STM32 Cube MX, which is the tool to configure the parameters for the microcontroller. We again need to provide the email and some information, and you get a link to download the software. After everything is installed, we can go to MATLAB Home, and in this option here, Set Path, we need to add the STM32 files, and we do that by clicking Add with subfolders, and then in my case it was installed in local disk, MATLAB, STM32 Mat, and STM32. Here you select and it will add those folders. You should see something like this when it's finished. We also need to install all the packages that are needed for the code generation with Simulink, which is several files. To begin with, we need Simulink. We also need the Simulink and MATLAB embedded coder. And then we need embedded coder, MATLAB coder, and the support package for ARM. The support package will be directly installed, so we don't need to install it separately. Okay, once we have the Simulink and MATLAB set up, we can go to the Cube MX tool and we can create a project by selecting here Start my project from MCU. We can now see a list of microcontrollers, and in our case we will select the STM32 F407, and we will select this option VG, which is the one that's included with the discovery board. We click here and press Start Project. Now we can see a picture of our microcontroller with all the pins. And now for this demo we will set up GPIOs corresponding to the LEDs and also the GPIO corresponding to the button. The button is in PA0, so we will click here and select GPIO input. And then for the LEDs, it's in some some of these. I will check the schematic. LEDs, and we can see that green, red, blue user LEDs are connected to PD13, to PD12, PD14, and PD15. So we select here GPIO output, and the same for the other ones. Okay, now we have the configuration that we need for this demo. We can set up additional peripherals for the microcontroller here. For example, communication protocols or timers or analog to digital converters and other things. But we won't do that for this demo. Now that this is done, we can go to Project Manager, and we give a name to this project. We will call it Simulink test, and we can save this in a folder, and we will select here which toolchain we are using. We are going to use the embedded workbench from IR, and once this is done, we can just go on File and Save Project. And now we can check that this project was successfully created. We can see Simulink test here, and we can see the IOC file, which contains a configuration that Simulink will need. Now we can go to this folder, and we can create a new Simulink model. And I will name it with the same name, Simulink test. Now we can open the model. Now before doing anything, we need to set up the Simulink solver to work with the code generation. For that, we open the settings, and first we change from variable step to fixed step, and we select infinite for stop time, and we select a step size. It's auto, we will change it to 1 millisecond. Next, we need to go to code generation, and here where it says system target file, we need to select the target file for the STM32 platform. If the installation of the Simulink support package was successful, we will see now STM32.tlc here. We select that and press OK. And once this is done, if we click this small arrow here, we should see STM32 options and STM32 project files here. We click options, and we select STM32 Cube MX Path Update. And now we should see this screen loading. This means that MATLAB can access the Cube MX software. And then it should come here, the path to the executable file. And this will be used by MATLAB to generate this code. Now we can go back to code generation, and in build process, we select package code and artifacts. This is so the final file contains all the libraries that Simulink is using. Okay, so we are done for the configuration. Now we can press OK. And now we can open the library browser, and we should be able to see target support package for STM32 here. If this is not showing up, it means that the installation process was not correctly done. The next step is adding the STM32 configuration block. We just drop this block here. We double click and select the STM32 configuration file. We select the one that we previously created. Now MATLAB Simulink is aware of our microcontroller. You can see here STM32F407, and it is also aware of which peripherals are available. For example, if I add GPIO read, when I double click, it knows that pin 0 is available since it's the one that we selected here, pin 0 on GPIO port A. Now I have GPIO port A available as a input, and the same thing with output, GPIO write. If we click, we can see that we have GPIO D available and pins 12 to 15 available. I will select all pins and I will place it here. And now for this demo, we will make a very simple state machine that takes the input button and cycles through the other LEDs when the input button is pressed. So to add the state machine, we write chart and it will add a state flow chart. We can open the chart and we can write here the first state, which we will call green state, and in this state we will make the green LED go to 1 and all the other LEDs will go to 0. Now for the red state, I will just copy this and red state goes to 1, blue state, blue state, blue goes to 1, and orange state, orange goes to 1. And now we can just draw the transitions here like this, and we can add the transition condition as button equals 1, and the same here. Now it seems that it was not responding. Let's see if it. Okay, now. And the last transition. Okay. Now these variables are not defined, so our chart won't be able to compile. But we can go here and Model Explorer, go to chart, and add the data. We can add the data one by one, or we can just don't do anything and try pressing compile, and it won't be able to compile, but it will give us a solution for the errors, and the solution is adding the errors as inputs and outputs of the chart. Now we can see that we have errors, and here we can see the symbol wizard is suggesting that we add button press as input and the LEDs as output. We can just press OK and it will be added. Now we want that the LEDs change when we press the button and not if we keep the button pressed. So for that we will add a rise detect block to the input, and then we can just connect the LEDs to the output. If we want to match the names to the pins, we should go to the datasheet and check that which pin is each color. We can see that 12 is green, orange 13, red 14, and blue 15. So the order should be green, orange, red, blue. We can go to the Model Explorer, chart, contents, and change the port. And we set green, orange, red, blue. So green should be 1, orange should be 2, red 3, and blue 4. Okay, that seems correct. And now we can just connect all the pins to the output of the state machine. Okay, so now our model is ready to be compiled. We can press Ctrl B or this button here for building the model, and this will automatically generate the C code. Now we can see that the STM32 tool opens. That's because the Simulink coder is using that tool to generate the code using the libraries from STM. We can see here that it's building, and if we check the diagnostic viewer, we can see step by step what it's doing. Now it's creating the HTML report. One very good thing of the coder is that we can see each block. We can see the corresponding C code for each block. Now you can see here that it says generating user source code. So it's generating the code for this Simulink block, Simulink model. And now it's generating the embedded workbench project. And once this is done, we can click on a block and see that code exactly, that block exactly which lines of code it's generating. Okay, the building process is now ready and it was successful. And now we can see the what I was talking about is seeing the C code that's generating. If we right click on a block and we press C code, navigate to C code, we can see which file and which line of code this block is generating. So here it's a GPIO read command. So we can see that the Simulink coder is using the HAL GPIO read pin function from the STM32 HAL libraries. If we check, for example, the GPIOD, we will see that similarly it's using the GPIO write of the HAL libraries. Here it's creating the masks of files that it needs to write, and then it's using the GPIO this mask to write on the output data register of the microcontroller. The output data register of the GPIOD. Okay, now we can go to the folder that we saved our Simulink, and we can see all these files are generated automatically. And we need to open the one in EWARM folder, and then we need to open the project.ww, and this will open the embedded workbench. Now we can take the STM32 discovery board and we can connect it to the USB port. Here we can see the STM32 board and it's running some old code. So now the project has been loaded and we need to press make to build all files, and it should compile without errors. Here we can see all the files that are being compiled. Total number of error 0 and warning 0. Now we can press this play button, so it will download and start debugging on the microcontroller. And we can see here that these LEDs start flashing, and that means that there is code and binary files being sent to the microcontroller. Now we can see that the debugger has stopped in the beginning of the main function, and we can just press play, this button, go, and it will start the main function. So now the code is executing, and we can just press this button here, and it will start cycling through the LEDs. Since we had this positive rise detection block, if I keep the button pressed, it's not changing. It only changes when I press, so it detects the positive rise. Okay, this concludes this tutorial on STM32 Simulink code generation. If you like the video, don't forget to press like, subscribe, and share it with other people that might find it interesting. Hej då!